This parametric equation notes, it says consider the path of an object along the curve y equals negative 2x squared plus 9x plus 20. This equation relates the height of an object with respect to time where x is greater than or equal to 0. If you notice, it looks like a quadratic equation, a parabola upside down. It says, although this equation tells you where the object has been or is going vertically, it doesn't tell you where the object has traveled horizontally or where the object is going or was at a given point, x comma y. I'm going to add to this horizontal component. You can introduce a third variable t. It's often time, and this is called the parameter. This creates a set of parametric equations in the form right here, where x is x of t and y is y of t. Evaluating both equations for a value of t gives you the coordinates of time, horizontal and vertical positions of the object at time t. It says, imagine the object of a falling raindrop. The following set of parametric equations describe the position of a raindrop where t seconds after it has left the cloud. It says x of t is equal to 0.5 t and y of t is negative 5t plus 50. It says find a position of the raindrop at time where t equals 4 seconds. So all we need to do, it says if we've got t here, is plug that in. So I'm going to say x of 4 is equal to, and I'm going to plug that in, so 0.5 times 4. So x of 4 is equal to 2. Do the same thing for the y equation. So y of 4 is equal to negative 5 times 4 plus 50. So y of 4 is equal to 30. And again, up here, it said to write it in an ordered pair, so that would be 2 comma 30. And that would be your answer. That would be your position. Okay, for B, at what time is the position of the raindrop at 4 comma 10? So now we know our answers, basically. So take your x comma t and set it equal to 4 and go backwards. So that equation was 0.5t. Set that equal to 4, and your answer is t equals 8. Do the same thing with y of t. Set that equal to, they said 10. So that was negative 5t plus 50. Set that equal to 10 and solve, and t is equal to 8. So time is equal to 8. They should be the same. On C, it says sketch the path of the raindrop over the time interval from 0 to 8. And in order to do this, what I would do is do a t-chart, except it's going to look a little bit different. You've got t, you've got x, and you've got y. Okay, so from 0 to 8, I'm going to do 0, 2, 4, 6, 8. Okay, so when we plug it into, I'm plugging it into my equation here. So 0.5t and negative 5t plus 50. So when you plug in a 0 to this, of course you get a 0 value. When you plug in a 2 to 0.5, that's 1. A 4 times 0.5, you get 2. 6 times 0.5, you get 3. And 8 times 0.5, you get 4. Same thing into my y value. So I'm going to plug in a 0 to my y equation. So 0 times negative 5, plus 50 gives me a 50. 2 times negative 5 plus 50 gives me a 40. 4 times negative 5 plus 50 gives me 30. My lines are getting kind of off here. 6 times negative 5 plus 50 gives me a 20. And my last one, 8 times negative 5 plus 50 gives me a 10. Okay, just like any old graph, I am going to do my x of t here and my y of t here. So all this right here, my t value was to help me find my x and t. So I'm going to mark that out real quick. So I need to graph my x and y values. Okay, now all you need to do is go ahead and plot your points. Change colors just for the heck of it. So 0, 50, 140, 230, 320, and 410. And so my graph is decreasing like this. And this is a parametric equation, so we can show that it's decreasing like this by arrows. This is the way it's going. Okay. All right, it says, when does the raindrop hit the ground? Now, when it hits the ground, you can think of this as my height equaling 0. And so which equation can you think of this? So I'm going to do my y of t is equal to 0. So I'm going to use my y equation, which is negative 5t plus 50, and go ahead and just set that equal to 0 and solve, which gives me a t is equal to 10. Okay, therefore, when does it hit? When t is equal to 10. All right, it says, how far has the raindrop traveled horizontally? Now, horizontally is going to be my x of t value from the time it left the cloud to the time it hit the ground. So from the time it hit the cloud, well, I know that it hit the ground at when time was 10. So I'm going to say x of 10 minus when it started at x of 0. So at x of 10, it hit the ground at 5 minus x of 0, which was 0. And you can actually continue your chart. Whoa, that's really bad. You can continue this graph, or you can continue your chart to find out when it actually hits, which was 5. And that would give me an answer of 5. Okay, my next question says, by plotting the points in the order of increasing value of t, the curve defined by a set of parametric equations is traced out in a specific direction. And this is called the orientation of the curve. So I've given you two different equations again, two parametric equations. X of t is equal to t plus 1, and y of t is equal to t squared minus t, 2 times t. And I've given you a new boundary here, so negative 1 to 4. It says sketch the curve. So I'm now going to do another t chart where I've got t, I've got your x and your y. And I want to go from negative 1 to 4. So negative 1, 0, 1, 2, 3, and 4. And again, I'm plugging it into these equations that I gave you, your parametric equations. So if you plug in negative 1 to your x value, you're going to get 1, 1, I get 2, 3, 4, and 5. I'm now going to plug these t values into my y equation to get my y values. And I get 3, 0, negative 1, 0, 3, and 8. And again, when I'm graphing, which I'm about to do right now, I am graphing my x of t and my y of t. I'm not using this at all, okay? So my x values are 0, 1 through 5. And I'm going to go ahead and just use these values as is. You can change it if you would like to, but I'm just going to use it. So I'm doing negative 1 and just counting up by ones. Now that you have your graph set up, go ahead and plot your points. And now you can see that when you connect these, that you get a graph that kind of looks like a parabola or half of a parabola. It says write the corresponding rectangular equations by eliminating the parameter. Okay, so how you do this is I'm going to take both equations from above. So my x equation is t plus 1, and my y equation is t squared minus 2t. Let's see. The easiest way to do this is to take your x equation and solve for t, and that would be t equals x minus 1. And I'm going to substitute it in here. So that would be y equals, my t value is now x minus 1. That's going to be quantity squared. And this is going to be 2 times quantity x minus 1. This now right here should be my answer. Now what I want you to do is to take this answer right here, plug it into your calculator, just normal everyday y equals, and see if it looks like this parametric equation, and it should match. Okay, I hope that helps. I'll see you in class tomorrow.